So what if you could have a perfect digital copy of yourself? I'm not talking about a static model, but a living, breathing simulation of you powered by AI. Today, we are diving deep into that exact quest, and believe me, it is one of the most exciting frontiers in all of science.
Just take a second and really think about that. A digital twin that ages, that reacts, that even heals just like you do. This isn't science fiction anymore. This is the real, tangible goal of a revolution happening at the intersection of medicine and artificial intelligence, and it is absolutely poised to change everything about how we understand our own health. All right, so here's how we're going to break this down. First, we'll start with the big idea, the dream of a digital human. Then we'll look at how we're currently simulating the body, piece by piece. After that, we're going to get into a mind-blowing AI that is literally learning to generate a living heart. From there, we'll look to the future, to the ultimate goal, something called zygote AI. And finally, we'll talk about why this should matter to every single one of us.
This dream of a digital human, it's not new. Scientists have been chasing this for decades. But to really understand where we're going, we first have to get a handle on where we are right now.
We have these amazing tools like Zygo Body or Body Parts 3D. They're basically Google Maps for human anatomy. They give you these stunning, incredibly detailed layer-by-layer blueprints of the body. I mean, you can see every single muscle, every bone, every organ. But here's the catch. They're static. They show us all the parts, but they don't show us how the engine actually runs. And to get that engine running, to make these models dynamic and alive, researchers are taking two pretty different paths. And this is where things start to get really, really interesting. So the first path is what you might expect, mechanical simulation. Think of it like building all the individual parts, the bones, the muscles, the tendons, and then dropping them into a sophisticated physics engine to see how they all move together. But the second approach, it's much more radical. It's called biological generation. And here, we don't build the model ourselves. Instead, we teach an AI to grow it, learning directly from tons of real-world data. Now, that mechanical path is incredible in its own right. Take a project called MyoSim. It creates these super complex musculoskeletal models for physics engine called MuJoCo. They've built things like the MyoHand, a simulation with 23 different ways it can move, all powered by 39 individual virtual muscles. This is how we simulate the raw physics of movement. It's like having a perfect, hyper-realistic computer model of a car's engine and running it in a simulator to see how it works. But what if you don't just want to simulate a pre-built engine? What if you wanted to learn the fundamental rules of how engines are built in the first place so you could generate a brand new one for any purpose you can imagine? Well, that's the core idea behind the AI approach. And let's look at how it works with the human heart. The key piece of technology here is something called a generative model. Most AI we hear about is discriminative. It's designed to classify things. Is this a picture of a cat or a dog? A generative model is totally different. It learns the very essence of catness so deeply that it can create a picture of a brand new cat that has never existed. And now, scientists are applying that same idea to human organs. So a recent study came out with a model called Mesh Heart. This is where it gets just brilliant, so let's walk through this. Step 1. An encoder studies the 3D shape of thousands of real hearts from MRI scans. It just learns what a heart looks like. Step 2. A transformer, and this is the same kind of tech behind things like ChatGPT, learns how that shape moves through an entire heartbeat. Finally, step 3. A decoder takes your personal info, your age, sex, weight, height, and uses everything it's learned to generate a brand new, unique 3D heart that beats just like a healthy heart should for someone with your specific profile. Now this lets us do something that's never been possible before. We can take your actual heart and compare it to the AI-generated ideal heart for you. That difference, the gap between the two, they call that the latent delta. It's basically a single, powerful score that captures any tiny deviation from your personalized, healthy norm. This isn't just another data point. It's a completely revolutionary new type of biomarker. So how powerful is this really? Well, in a test to classify myocardial infarctions, that's heart attacks, the traditional metrics from an image got an accuracy score of about 0.83. But get this, using only the AI's learned features, its latent vector, it did even better. And when you put them together, the accuracy gets a huge boost. This is real proof that the AI is seeing clinically relevant patterns that our best tools have been missing all along. Okay, so we can generate a heart. That's incredible. But a heart is just one component, right? The true endgame here is, well, it's a lot more ambitious.
It's about moving from simulating the parts to growing the entire system from the ground up. This quote really captures the huge shift in thinking. The idea that physics simulators like Mujoko, as useful as they are a dead end for creating a true digital human. The future isn't about simulating parts that we've already built. It's about using an AI to generate the body itself, to learn the fundamental rules of growth. And that brings us to this theoretical holy grail, a zygote AI. The idea here is to create a model that doesn't start with an adult body, but with a single digital cell. It would have to learn the DNA growth algorithm, the fundamental rules of development, to grow a complete human body from scratch. In this kind of model, the AI's output isn't a body. The output is the next step in that body's continuous growth. It would be a truly living simulation. When you put them side by side, you really see the leap we're talking about. Current models, as amazing as they are, focus on individual parts, right? A zygote AI would be a whole body system. Current models simulate pre-built parts. A zygote AI would generate and grow them. And maybe the most important difference, it wouldn't just rely on an external physics engine. It would learn and integrate the laws of physics and biology right into its own structure. Let's go back to our car analogy one last time. We started with a static photo of a car. That was our old anatomy models. Then we moved to a hyper-realistic simulation of its engine. That's where we are now with things like MyoSim and Mesh Heart. A zygote AI, that's the final leap. It's not the car or the engine, it's the entire virtual factory that understands from first principles how to design, build, and test an infinite variety of new cars from raw materials. So, this all sounds incredibly futuristic, I know. But why should you care? What is the actual, real-world impact of creating these digital twins for people like you and me?
Honestly, the potential is just staggering. With a personal digital twin, we could completely shift medicine from being reactive to being predictive. We could simulate your health's trajectory and see diseases coming years in advance. We could test hundreds of different drugs on your digital twin to find the perfect one for you with zero risk. Surgeons could rehearse a complex operation on your virtual body 10 times before ever picking up a scalpel. We could even begin to simulate and maybe finally understand the process of aging itself.
And if you think this is all just theory, something happening in a tiny lab somewhere, remember this number, 38,309. That is how many people's data from the UK Biobank was used to train just the Mesh Heart AI alone. This is not a small experiment. This is big science, powered by massive real-world data sets, and it is happening right now. Which brings us to the final and maybe most important question. The technology to create these digital twins is moving forward way faster than we can imagine. Soon, it might be possible to predict your health decades into the future with terrifying accuracy. So the question really isn't if we can do it anymore, it's what we'll do when we can. If you could see your future health laid out for you, would you want to know?